Hello students, today we'll see reactions involving alpha hydrogen atom, and in that we'll see two major name reactions. One is aldol condensation and the second one is your Cannizzaro's reaction. So reactions due to alpha hydrogen, acidity of alpha hydrogen of aldehydes and ketones. The aldehydes and ketones undergo a number of reactions due to the acidic nature of alpha hydrogen. The acidity of alpha hydrogen atoms of carbonyl compounds is due to strong electron withdrawing effect of the carbonyl group and resonance stabilization of the conjugate base. So you can see here the reaction, and we'll deal in detail about two major reactions, aldol condensation and Cannizzaro's reaction. Aldol condensation is further subdivided into two types. One is plain aldol condensation and the second one is cross aldol condensation reactions. So aldol, as the name says, aldol is a combination of two functional groups, aldehyde and alcohol. So aldehydes and ketones containing at least one alpha hydrogen atom in them in presence of a base dilute alkali that acts as a catalyst results in the formation of beta hydroxy aldehydes called as aldol or beta hydroxy ketones, ketol respectively, and this is known as aldol condensation reaction. So 2 moles of ethanol, this is plain aldol condensation reaction. Two same molecules of ethanol react with one another in presence of a base dilute NaOH, and it results in the formation of 3-hydroxybutanol. So this is aldol. So here you see the presence of the functional group aldehyde, and since OH is present in beta position, this aldehyde is named as beta hydroxy aldehydes, commonly called as aldol. This loses water molecules on heating and it results in the formation of alpha beta unsaturated compounds, and the product that is formed, aldol condensation product that is formed here is but2-ene-1-al. I'll show you here on the board the reaction of ethanol CH3CHO. HCHO, since it does not contain alpha hydrogen atom in it, will not undergo aldol condensation reaction. So we'll proceed with the next aldehyde containing compound, and it is CH3CHO, ethanol. Okay, this is your functional group. The carbon that is present next to this aldehyde group is your alpha carbon, and this is having alpha hydrogen atom in it. So two same molecules of aldehyde, this is also CH3CHO, combine with one another in presence of dilute NaOH, and it results in giving you beta hydroxy compound that is aldehyde, and it is called as aldol. So see the aldol product CH3CH, this H will combine with oxygen. Actually it results in the formation of enolate ion. So OH will be formed, CH attached with OH. This H combines with O forming OH, and that OH gets attached with the CH, CH2, CHO. Okay, so this is very unstable. On heating, it loses water molecule there. It loses one molecule of water, and it results in the formation of alpha beta unsaturated compound. So see here, the compound that is formed is CH3CH. This becomes double bond CH, CH, O. And the compound name of this compound is 1, 2, 3, 4. So it is but 2 in 1 I. In I you can write it together. The name of this compound is but 2 in 1 I. And this is alpha beta unsaturated hydrocarbon that is formed during the reaction. This is plain aldol condensation reaction. Hope you have followed. So two same molecules of aldehyde can react with one another in presence of a dilute base, forming aldol, and this is unstable, removes on heating water molecule and results in the formation of but 2 in 1 I. Similarly, propane 2-one on treatment with barium hydroxide results in giving you ketol 4-hydroxy 4-methyl pentane 2-one, and this removes water molecule resulting in the formation of aldol condensation product 4-methyl pent 3-ene 2-one. And the basic requirement for these reactions to undergo aldol condensation is aldehydes and ketones containing at least one alpha hydrogen atom in them. So two same molecules of aldehyde or two same molecules of ketone in presence of dilute base, they react resulting in the formation of aldol. If it is an aldehyde, aldol. It is a combination of two functional groups, aldehyde and alcohol, or ketol, ketone and OH group. OH is always there on the beta position and beta carbon atom, and it removes water molecule resulting in the formation of aldol condensation product, and such reactions are called as aldol condensation reactions. Next I come to cross aldol condensation reaction. All the reactions today which I am teaching are very important from board point of view. You will study both the reactions in detail with full concentration because question is asked from this part of the name reaction, either aldol condensation, cross aldol, or Cannizzaro's reaction. So I deal with second reaction. It is cross aldol condensation reaction. So here two different aldehydes you can take or two different ketones containing at least one alpha hydrogen atom in them in presence of a base undergoes condensation reaction, and it results in the formation of four different products if both the reactants are containing alpha hydrogen atom in them. So you see here I have started with CH3CHO plus CH3CH2CHO. CH3CHO is ethanol. This is containing alpha carbon, on it is alpha hydrogen. Similarly, CH3CH2CHO, the second carbon, that is the carbon next to this functional group CHO, CH2, this carbon, this is containing alpha hydrogen atom on it. This is alpha carbon and on it it is having alpha hydrogen. So both the compounds, that is ethanol and propanol, are containing alpha hydrogen atoms in them. So they undergo aldol condensation in presence of a base, and it results in the formation of four products there. Self-aldol products they will be giving. So self-aldol products is formed from two same molecules of ethanol and two same molecules of propanol, and cross aldol products are formed from one molecule of ethanol and one molecule of propanol, or one molecule of propanol and one molecule of ethanol, resulting in the formation of four different products. I'll show you here on the board the reaction. The reaction of ethanol and propanol. So here you see, I write the same equation, but it is cross aldol condensation. Here in place of, this is ethanol and this is propanol, CH3, and I make this CH. CH3, CH2, CHO. So two same molecules of ethanol, if they react with one another, it results in giving you self-aldol products. Two same molecules of propanol, if they react with one another, they result in the formation of self-aldol products. And one molecule of ethanol and another molecule of propanol will give cross-aldol products, and one molecule of propanol and ethanol will give you again the cross-aldol products. So four different products are formed. If it is CH3, CHO, two same molecules of ethanol, the product that is formed is CH3, CH, double bond CH, CH3. That is, sorry, it's CHO. CHO. That is, as I showed you in the first reaction, and the name of this compound is but-2-ene-1-al. But-2-ene-1-al is formed. Two same molecules of propanol, if they react with one another, it results in giving you 2-methyl-pent-2-ene-1-al. This is 1-al. 2-methyl-pent-2-ene-1-al. So the name of this compound is this. It is CH3, CH2, CH, CH, CHO. So the name of this compound is 2-methyl 1,2,3,4,5 pent-2-ene-1-al. 2-methyl pent-2-ene-1-al. This is the second product that is formed. The third product will be formed when ethanol and propanol will react with one another. I'll write just the name of the compound. It is 2-methyl-but-2-ene-1-al. 2-methyl-but-2-ene-1-al. Let me draw the structure. 2-methyl-but-2-ene, 1, 2, 3, 4. 1-al, it is CHO. 2-methyl is methyl group present here, CH3. 2-methyl-but-2-ene, 1-al. So satisfy using CH3, CH and CH. And the name of this compound is 2-methyl-but-2-ene-1-al. 2-methyl-but-2-ene-1-al. Okay, and the fourth product that will be formed is plus. The fourth product that will be formed is, this is four different products are formed in aldol condensation products, remember. And the fourth product is pent-2-ene-1-al. This molecule and this molecule, and it results in giving you pent-2-ene-1-al. And this is the compound that is formed. CH2, CH and CH. And the name of this compound is pent-2-ene-1-al. Hope it's clear. And this is cross-aldol condensation products. Once again I say, ethanol and propanol both are containing alpha hydrogen atom in them. This is your alpha carbon. One of the hydrogen is alpha hydrogen. This is your alpha carbon. One of the hydrogen is your alpha carbon. So two same molecules of ethanol will give self-aldol product but-2-ene-1-al. Two same molecules of propanol will give you self-aldol product 2-methyl-pent-2-ene-1-al. One molecule of ethanol and one molecule of propanol will give 2-methyl-but-2-ene-1-al. And one molecule of propanol and one molecule of ethanol will give you pent-2-ene-1-al. This is how you'll answer the question related to that of aldol condensation products. Next, I'll show you the reaction of ketone. Ketones can also be used as one component in the cross-aldol condensation products. This benzaldehyde doesn't contain alpha hydrogen atom, but this C6H5COCH3, this is the compound which you have taken, acetophenone C6H5COCH3, in presence of a base at 293 Kelvin results in giving you benzyl acetophenone, which is the major product that is formed. So here only since one molecule is having alpha hydrogen atom on it, it results in the formation of the product, that is 1,3-diphenyl prop-2-ene 1-one is the product that is formed. Hope it's clear. Next reaction I come to, and it is other reactions, that is Cannizzaro's reaction. So in aldol I said aldehydes and ketones containing at least one alpha hydrogen atom in them. Here I am saying in Cannizzaro's reaction, aldehydes only. Ketones do not undergo Cannizzaro's reaction. Aldehydes only which do not contain alpha hydrogen atom. So aldehydes which do not contain alpha hydrogen atom undergo disproportionation reaction. Disproportionation reaction is self-oxidation and self-reduction of the same molecule takes place on treatment with concentrated solution of a base, that is conc alkali. In this reaction, one molecule of the aldehyde is reduced to alcohol while another is oxidized to carboxylic acid salt. So you can see the reaction HCHO. In the beginning when I taught you about aldol condensation, there I said formaldehyde, that is methanol, cannot undergo aldol condensation reaction due to the absence of alpha hydrogen. So methanol and benzaldehyde will undergo Cannizzaro's reaction. Both are aldehydes which do not contain alpha hydrogen atom. This is the condition here. Aldehydes which do not contain alpha hydrogen atom in them, they undergo disproportionation reaction, that is self-oxidation and self-reduction in presence of concentrated base, in which one of the molecule gets reduced to alcohol and the other molecule gets oxidized to sodium or potassium salt of carboxylic acid. So HCHO, two molecules of HCHO, that is methanol, on treatment with conc KOH gets reduced to alcohol CH3OH plus potassium formate HC double bond OOK. HCOOK is formed. Similarly, benzaldehyde reacts with concentrated solution of NaOH and it results in giving you benzyl alcohol C6H5CH2OH and sodium benzoate C6H5COONA. So this is Cannizzaro's reaction. Both the reactions, once again I am repeating, aldol and Cannizzaro's reactions are very, very important. So learn them well. Next type of reaction I come to, it is electrophilic substitution reactions. So aromatic aldehydes and ketones undergo electrophilic substitution at the ring in which the carbonyl group acts as a deactivating and meta-directing group. So benzaldehyde undergoes nitration reaction in presence of a nitrating mixture, conc HNO3 in presence of conc H2SO4, low temperature 273 to 283 Kelvin. It undergoes electrophilic substitution reaction resulting in the formation of meta-nitrobenzaldehyde. That NO2 groups comes in the meta position, forming the product meta-nitrobenzaldehyde. Hope it's clear. Yes, look at this question. The question is, arrange the following compounds in increasing order of their reactivity in nucleophilic addition reactions. First one is ethanol, propanol, propanone and butanone. I told you while I was teaching you that aldehydes are more reactive in comparison to that of ketones due to two reasons. One was steric factor and the other was electronic factor. So since you need to write it in increasing order, first comes butanone. This is least reactive, increasing order of nucleophilic addition reactions. So butanone, put the less than sign. Propanone, put the less than sign. Propanol, less than sign. Ethanol. I repeat my answer. Butanone, less than sign. Propanone, less than sign. Propanol, less than sign. Ethanol. Then second part of the question, benzaldehyde, paratolualdehyde, paranitrobenzaldehyde and acetophenone. I said ketones are least reactive, so first comes in increasing order of the reactivity acetophenone, since it is a ketone. Next comes the presence of the CH3 group, that is electron releasing group, that decreases the reactivity power in nucleophilic addition reactions. So first comes acetophenone, next is paratolualdehyde, less than sign benzaldehyde, and the presence of electron withdrawing group increases the reactivity. So next, last comes in increasing order paranitrobenzaldehyde. Once again I repeat my answer. Acetophenone, less than sign paratolualdehyde, less than sign benzaldehyde, less than sign paranitrobenzaldehyde. Acetophenone, paratolualdehyde, benzaldehyde and paranitrobenzaldehyde is the increasing order. Always put less than sign when the question is asked to write it in increasing order. Next is predict the products of the following reactions. I'll show you that. Predict the products of the following reactions. I'll show you here on the board the reactions. And the first question is, it is pentanone treated with that of hydroxylamine NH2OH. Okay. So remove the water molecules. I asked you to learn the table of ammonia and its derivatives and form the product. The product that is formed is double bond attached with that of NOH, that is an oxime is formed. Oxime is formed. Similarly, the second part of the question, it is given cyclohexanone. So cyclohexanone, when it is treated with that of cyclohexanone, when it is treated with that of 2,4-DNP. 2,4-DNP is 2,4-dinitrophenyl hydrazine. So I am writing the structure of it plus NH2, NH, draw the benzene ring containing compound. Okay. Second position put NO2 and fourth position, this is your fourth position, put NO2 and make the product. Remove H2O from here. H2O you are removed and the product that is formed is this cyclohexane ring, double bond attached to that of NH, C6, this compound benzene ring, NO2 is there on second position and NO2 is there on fourth position respectively. So this compound is 2,4-DNP. DNP stands for dinitrophenyl hydrazine. So dinitrophenyl hydrazine results in the formation of dinitrophenyl hydrazone. So the product that is formed is this. Double bond, attach it with NH, 2,4-dinitrophenyl hydrazone is formed. C6, this benzene ring you draw, NO2 group you put here, NO2 group, NO2, and fourth position you add NO2. So 2,4-dinitrophenyl hydrazone is formed during the reaction. This is the second part of the question. The third part of the question is, it's treated with semicarbazide and it results in giving you semicarbazone. So the compound that is given is RCH double bond CH, RCH double bond CH, CHO, treated with that of semicarbazide. So I'll write NH2, NH, C double bond O, NH2. Remove, you can not remove the hydrogen from this nitrogen there because this is attached with this C double bond O compound here. So the forces of attraction are very strong. Since it is an amide linkage, you cannot remove the hydrogen water H2O from the NH2 group that is attached directly with that of carbonyl group. The NH2 group that is far away from that of the carbonyl group, you can remove water molecule from that carbon atom there. And the product that is formed is RCH double bond CH, single bond CH, double bond N, NH, C double bond O, NH2. That is semicarbazide results in giving you semicarbazone product is formed. And the fourth reaction is benzene is the ring that is given attached with C double bond O CH3, that is acetophenone C6H5COCH3, treated with NH2 amine, it is CH2CH3. So this results in giving you substituted water molecule is removed out. This is removed out and it results in the formation of the product that is substituted amine. And the product that is formed is this product CH3, you can write it on the top, double bond, connect it with N here, CH2, CH3. So this is the product that is formed during the reaction. I hope you have understood and it's clear to all of you. Next we come to the last part, that is the uses of aldehydes and ketones there. So uses is very simple. Chemical industry, aldehydes and ketones are used as solvents, starting materials and reagents for the synthesis of other products. We know formalin, that is formaldehyde solution, 40% solution of formaldehyde is used to preserve biological specimens and to prepare bakelite, a phenol formaldehyde resin, urea formaldehyde glues and other polymeric products. Acetaldehyde is primarily used as a starting material in the manufacture of acetic acid, ethyl acetate, vinyl acetate, polymers and drugs. Benzaldehyde is used in perfumery and in dye industries. Acetone and ethyl methyl ketone are commonly used as industrial solvents. Many aldehydes and ketones, example butyraldehyde, vanillin, acetophenone, camphor, etc., are well known for their odors and flavors. In the next class, we'll start with carboxylic acids. And till then, thank you children and have a nice day.